Okay, and this is another Wingdinger standard, okay? I want you to write this, write square root -1, okay? And then go on the assignment and you're going to cross out number 1, okay? I don't need you doing that. Okay, look what happens when I square root a negative. Get domain error. That's because negatives don't really have square roots. It's not 1. 1 times 1 is positive 1, not -1. -1 times -1 is also positive 1, not -1. Okay, here's what we're going to have to do, and I don't like this standard either. I can't find anything good to really apply it to. I'm going to write this as the product of two square roots. Okay. I'm actually going to write that as -1 and 1. Well, the square root of 1 is 1. Okay, we know that. Okay. The square root of -1 is equal to I. Okay, so 1I. If I had a square root of -4, I would write that as a product of two square roots. Take a -1 out, and then I get 4. So that's 2, and that's I, so that's 2I. Square root of -16. Product of two square roots, that'd be -1 and 16. -16 divided by -1, 16. That's I, and that's 4, so 4I. Now, that's letter I. It has to do with negative numbers under square roots. Now first, I got some problems here that I want to do. I'm going to multiply this out just like I do regularly. 6I times -3I and 6I times 7. It's -21I to the second, and that's going to be 42I. Now, so -21I to the second plus 42I. Now, when you're using the letter I, whenever you have an I to the second, you need to circle it and replace it with a -1. So that's positive 21, and that's 42I. Okay, anytime you end up with I to the second, that is what we're going to do. Here's why you do that. We already know that the square root of -1 is equivalent to I. Now if I square both sides, the square root and the second cancel, and that's I to the second power. That's how it works, okay? Alright, now, FOIL. 4 times 6, 4 times -4I, 2I times 6, and 2I times -4I, so that's going to be 24, -16I, 12I, and -8I to the second. So -8I to the second, I collect like terms here, it gives me -4I, and then 24. But whenever I have I to the second, we need to replace that with -1, and now that's 8 plus -4I plus 24. Now that that's 8, we have like terms here, 8 and 24. That's 32 plus -4I. Okay, same idea here. So 3 times 2, 3 multiplied by -8I, 4I multiplied by 2, and 4I times -8I. So that's 6, -24I, 8I, and -32I to the second. So I have -32I to the second. I collect like terms, it's -16I plus 6. Now the I to the second is equal to -1. So -32 times -1 is 32 plus -16I plus 6. Now I need to add 32 and 6. So 38 plus negative 16i. Your whole goal when you multiply with these i's is to end up with a number with an I and a number without an I. It's how that's always going to work. It's called a complex number. We don't use it for a lot in here. Complex number. Number 2 on the assignment. If you want to pause the video and do it, that's fine. Okay, I just want to look at one on the next page here. Okay, 25 is a perfect square, but since it's negative 1 and 25, that's I and that's 5, so that's 5i. 5i, it's going to be negative 25i, never mind. Don't do that, I don't know what I was doing. Okay, 20, not a perfect square, so I go like this, and I'm actually going to divide by not only 4, but negative 4, I get 5, okay? Alright, so that's going to stay the same, but this right here, what I do is I make it positive, bring an I out, and that turns into 2. So it's 2i square root 5. Next one here, perfect square, so I make that positive, put an I right there, and square root of 16 is 4, so it'd be 4i. Square root of negative 13, okay? I can't really divide 13 by anything up there, so when I don't, I make that positive and put an I outside, okay? It's weird. Okay, now let's solve some equations. They're all like terms on these ones. There's 2 answers, but all you have is x squared. So I got x squared, I need to add 8 to both sides. So x to the second equals negative 28. Square root, x equals plus minus. Now anytime we have a negative under a square root, we have to make that positive and bring an I outside. Okay, so 28, I need to split that, and I can divide it from the board. I can divide it by 4, I get 7, so that's 2. So 2 square root 7, but you got to put your I, and the I goes right before the square root, okay? So 2i square root 7 and 2i square root 7 with a negative in front. Okay, next problem. Second power is all you have. When I have a negative, we make it positive, put an I out. Now 13 is a prime square root, so I leave it square root 13 and the I again in front of the square root. So I square root 13 and the same thing, put the negative in front of everything, okay? Just put the negative in front. 2 answers. Anytime we have a negative under a square root, we're going to just make it positive and bring out an I. What I'm really doing is factoring by a square root of negative 1, which is the same as I. So minus 11, it's negative 8. Anytime I have a square root, make it positive, bring an I out. And then see what 8 is divisible by. It's divisible by 4 and 2. Well, this is 2. So 2 square root of 2, and we always put the I in front of the square root. So 2i square root 2, 2i square root 2 negative. Minus 31, so 2x squared equals negative 24. Divide by 2. Negative 12. So x equals plus or minus. We got to extract the I out. 12, not a perfect square, so I make that. 12 is divisible by 4. 12 divided by 4 is 3. So it's 2. So 2 square root 3, but we did have an I, so I put that before the square root. So 2i square root 3, 2i square root 3 negative. Now pause the video and go do number 3. Or no, don't do number 3 yet. I want to make up another problem. Just watch me do it, okay? So there's 2 answers. I divide by 2. Square root, x is plus or minus, bring the I out. I don't need to do this because 49 is a perfect square. Right away it equals 7. So there's no square root in the answer, it's 7i, okay? So 7i, negative 7i. That's going to happen on number 3. You're going to end up with the square root of negative 25. You'll bring the I out, and that's going to be 5, so 5i. Alright, now solve. There's 2 answers. Now, unlike the last problems, we need to use factoring, not like terms. So, GCF and the T-chart. Now, you're not going to like these ones, I can just tell you that. GCF, okay. Alright, I don't have a GCF. 1 times 86, 86, positive sum of 18. I'm just going to tell you right now it doesn't work, so we go to the quadratic formula. Opposite of b, plus or minus c square root. B squared minus 4, 1, and 86, and 2 times 1 is 2. Now, I'm fine with decimals unless this happens, okay? Unless this happens. Domain error. If you get a domain error, this is what you have to do. You got to go 18. That's because you had a negative under a square root. So you make your 2 square roots. Negative 18 times itself. 4 times 1 times 86. 324 minus 4 times 1 times 86 is 344. And that's negative 20. So if I have a negative, I bring I outside. And we got to do this. 20, if you get a domain error, I don't want decimals. 20 is divisible by 4. So 4 and 5, and that's 2. So 2 square root 5, and I put that I right there. So the answer is 18 plus 2i square root 5 over 2. And 18 minus 2i square root 5 over 2. Now some of you are like, oh, I thought you could have decimals. Yeah, I'm fine with decimals, but if you get domain error, you really can't. 2 answers. Factoring is a way to go because you got this and this, so we get one side clear. And I have 9x squared minus 12x plus 7 equals 0. So it's 3 terms. GCF, there is not one. 9 times 7, 63. Sum of 12, I'm just going to tell you, it doesn't exist. So to the quadratic formula, opposite of b, plus or minus square root. Okay, so negative 12, 4, a is 9, c is 7, then 2 times 9 is 18. So again, you can punch the square root in, and hey, if it gives you something, more power to you, but whoops, nope. So negative 12 times itself, 4 times 9 times 7, that's 144. And I take 4 times 9 times 7, that's 252. Well, it's going to be a negative, obviously. I know it is because it's a domain error, so negative 108. Okay, so I extract an I out of there, and then I divide up on my board. 108 is divisible by 36. You get 3. So 6 square root of 3, put the I there. So 12 plus 6i square root 3 over 18. 12 minus 6i square root 3 over 18. Now technically, other teachers, I'm not going to make you, but other teachers, don't write this down, just watch, will make you take 12, 6i, and 18 and divide it down by common factors. These can all three, I don't care about that, that's in a square root. These all three can be divided by 6. So it'd be 2 plus or minus 1i square root 3 over 3. That's really the same answer as here. Don't worry about that, okay? Just know you can do it. Okay, now you're ready to do number 4. Remember to get the plus 25 over there. I'm actually going to help you out, so don't shut off the video yet. Hold on one second. I know I'm boring you to death, so I just want to make sure. I'm trying to save you some work. Okay, when you get your square root, you're going to bring the I out, and the number you'll be able to divide by, assuming you set it up right, will be 16. You will have a 96 in the square root, and you'll be able to divide that by 16 and 6, and 16 becomes 4, 4i square root 6.